For the second half of our combined lesson of 6, 7, and 8, these lessons 6, 7, 8 from our topic 1, we're going to continue learning about some special theorems. We're going to continue how to write some proofs. We're going to do some more thinking, although this is going to feel a little bit more algebraic, and so there may be a comfort level there that you'll appreciate. Lots of key vocabulary here, and we're going to start with vertical angles. Vertical angles are angles whose sides are opposite rays. If you remember from our first unit and our first lesson, we talked about opposite rays are those collinear rays that have the same endpoint but go in opposite directions. So this is a pair of opposite rays, and then this is a pair of opposite rays. And so that means that these angles 1 and 2, or these angles 3 and 4, are called vertical angle pairs. Vertical angle pairs. So when we're naming these angles, we are referring to pairs of angles. Vertical angles, we're talking about these two, and we're talking about these two. These two are vertical, these two are vertical angles. Adjacent angles. Adjacent angles are a pair of coplanar angles that share a common side, a common vertex, but no interior points. So in this case, these angles share a vertex, they share a side, but they don't overlap. So angles 1 and 2 are adjacent. It's a fancy word that just means next to. These are adjacent angles, but angles 2 and 3 are also adjacent angles. Angles 1 and 3 are not adjacent because they do not share a side. They do share a vertex, but they don't share a side. The sides for angle 1 are these rays. The sides for angle 3 are those rays, and they're not shared. Complementary angles. These are a pair of angles that have measures that sum to 90 degrees. Together, they make a right angle. Now, you can have a 45-degree angle on this side and a 45-degree angle on that side, and we would consider them complementary because they would, if put together, they would sum to 90 degrees. Their measures would sum to 90 degrees. So complementary with an E there. Each angle is called the complement of the other. And so they have measures whose sum is 90 degrees. All right, angles 1 and 2. Their measures add up to 90. Angles 1 and 2 are complementary. Or you can say angle 1 is the complement of angle 2. Angle 2 is the complement of angle 1. Next we have supplementary angles. These are sometimes called a linear pair. But supplementary angles are those angles whose measures sum to 180 degrees. So if you have a 90-degree angle and a 90-degree angle, I know that they're both right angles, but we could also call them supplementary angles because together a 90 and a 90 would add up to 180. A 100-degree angle and an 80-degree angle together would add up to 180. A 120 and a 60-degree angle, those would be supplementary. So angles 1 and 2 are supplementary because their measures add up to 180. We can say that angle 1 is the supplement of angle 2, and that angle 2 is the supplement of angle 1. So again, just different ways that we would use this term or this concept in various contexts. Most of the time, we're going to be told that angles are supplementary, but we're going to know that that means that their angles measures, that their measures sum to be 180 degrees. So that would, telling us this information would let us do some math. Right, that's kind of the whole goal. If we know about the angles, then we can then create equations using those angles. So here in a little bit, we're going to have a diagram up, and I want for you to be able to identify the complementary angle pairs, supplementary angle pairs, vertical angle pairs, and adjacent angle pairs. And so here we have a low resolution diagram, but we should note that we have a pair of angles that make 90 degrees. Angle 2 and angle 3 are complementary. We're always only talking about pairs, so 2. If we have 3 angles that add up to 180, we would not call them supplementary, right? So even though all 3 of those by the angle addition postulate make a straight angle, they are not supplementary angles because it's not a pair, all right? But angle 5 and angle 4, these angles do make 180 degrees, and they are a linear pair. There's only 2 of them, and so they make 180 degrees. There is another pair. Can you name the other? Name another pair of supplementary angles. Vertical angles. All right, so vertical angles. Angle 5 and angle 3 are vertical angles. All right? They have opposite rays there and there for sides. Adjacent angles, and we could list the whole ton. Angle 1 is adjacent to angle 2. Angle 2 is adjacent to angle 3. Angle 3 is adjacent to angle 4. Can you fill in the rest, fill in the other pairs? There's 2 more. Can you fill in the other 2? Example 4, making conclusions from a diagram. All right, so looking at a picture, what can we know? So let's take a look at this picture. Go ahead and draw that in your notes. You should have the last drawing in your notes as well, but have this drawing in your notes, and we can conclude a lot of information about angles 1, 2, 3, 4, and 5 based on what we're given in the diagram. The first thing to note is that angles 1 and 2 are going to be congruent to each other. That's a pair of congruent angles. Angles 1 and 4 are vertical. Angles 4 and 5 are supplementary. Angles 1 and 5 are supplementary. So we have a whole host of information to be aware of about these angle pairs. 1 and 4 are vertical, 1 and 2 are congruent. 1 and 5 are supplementary, 4 and 5 are supplementary. Do you notice that 3 and 5 are not vertical angles? All right? This angle and this angle are not vertical angles because while we have one pair of opposite rays here, this one doesn't have its buddy as a side for angle 3. And likewise, this side for angle 3 doesn't have its buddy here cutting through angle 5. And so we do not have a pair of opposite rays or pairs of opposite rays for angles 3 and 5. So that's why that is not a pair of vertical angles. However, this angle here and angle 5 are vertical angles. So this whole thing and that whole thing are a vertical angle pair. All right, but we don't have a number or a name for that, so I'm not going to name it based on this diagram. All right, we do realize that that's fact, but we don't have a name for it, so we can't really draw that conclusion right here. All right, for the second part of our notes, we're going to talk about theorems, and we're going to have theorems about those special angle pairs that we just mentioned. And so this is going to be information that is true, but it's also information that we can prove. And one of the key cornerstones of our class here in geometry for this school year is going to be proving these statements that we're making and using logic, deductive reasoning to make the case that these things are true. The first one is that vertical angles are congruent. Vertical angles are congruent. We know that this is true because these angles form a linear pair. They are supplementary. And these angles also form a linear pair. And so if we're going to prove that this is true, I can show that the measure of angle 1 and the measure of angle 3 make 180. I can also show that the measure of angle 2 and the measure of angle 3 is equal to 180. Right? We know that that's true based on the diagram. I know that these are supplementary angles and therefore their measures add up to 180. You could even in your logical thinking say that angle 1 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary. All right, this is given in the diagram. This is given in the diagram. This is by the definition of supplementary. We know what supplementary means. So by the definition of supplementary, we know that this is true. But we also can manipulate the situation a little bit. If we think about this, we're taking an angles measure plus the same quantity gives us the same sum. So logically, if 1 and 2 added with 3 gives us 180, then we know that 1 and 2 have to be the same amount. If this amount plus this same thing is equal to that, then these have to be the same. Here's a way that we can demonstrate that. If I write that I subtract the measure of angle 3 from both sides, I can show that the measure of angle 1 is 180 minus the measure of angle 3. And I can likewise show that the measure of angle 2 is equal to 180 minus the measure of angle 3. And so by using the addition property of equality, I can confirm my logic that if this is equal to that, And if that is equal to this, then these are equal to each other. Now you can either call that the transitive property, or most of us would like to say that that's substitution, POE, all right? The substitution property of equality, if I know that the measure of angle 1 is equal to that, and I know the measure of angle 2 is equal to that, then I can put measure of angle 2 in place of that in this equation to say the measure of angle 1 is equal to the measure of angle 2. And therefore, angle 1 is congruent to angle 2 by the definition of congruent. Okay? So what I've done here is not just told you some fun fact, but I proved it to you. Now, as we move on through here, I'm not going to do every single proof, but you can see that this is 1, 2, 3, 4, 5, 6, 7, 8 steps of deductive reasoning, of logic and reasoning and thinking about the things that we see in the diagram, the facts that we know. We're using definitions and properties to show that these angles are in fact congruent. All right? Now, hopefully you were able to follow through that logical process. And sorry for the handwriting, but hopefully you were able to think through all the things that I said and that made sense to you, all right? And it might not be something that you can do yet, but hopefully it is something that you will be able to do as we move through this class. Maybe on your exam, maybe on the next unit exam, maybe by December, all right? Sometimes it just takes a while to learn these things well. So let's go ahead and use that, let's apply that, and then we'll talk about some more awesomeness. If these are vertical angles, then I know that 2x plus 3 is equal to 4x minus 101. Draw that picture in your notes for full credit, label the diagram, and now we get to do math. I'm going to add 101 on both sides. I'm going to subtract 2x's on both sides. I'm going to divide by 2 to solve for x. All right? And so we can find the value of x by doing some quick, simple algebra 1. All right? Sometimes they might say plug that number back in to find the measures, make sure that they match up, but that's the way that you can check your own work. The congruent supplements theorem. Angles that are supplements of the same angle are congruent to each other. Or angles that are congruent to each other would be supplements of the same angles. All right, so this and its converse are both true. And so if we think about this in terms of a diagram, if angle 1 and angle 3 are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 and angle 2 have to be congruent to each other. Basically, folks, it's the same proof that we just did. It's the same 8 steps of thinking that we just used on the vertical angles theorem. All right? Basically, we're saying that if these are supplementary and these are supplementary, then these have to be congruent to each other, which was the same logic that we used in the last proof. The same goes with the congruent complements theorem. If we have angles that are complements of the same angle, then they are congruent. And vice versa. Angles that are congruent would be complements of the same angle. And so if we have, and I don't have a drawing here, but if I have, angle 1 and it's complementary to angle 3, and I have angle 2 that is also a complement of angle 3, then I know that angles 1 and 2 must be congruent. All right, moving on. Here are some theorems about right angles. These 2 right here. All right angles are congruent. That is probably a no-brainer, but we can easily show that if these 2 are right angles, then we know that their measures are 90, which means that their measures are equal, which means that those angles are congruent. It seems like a silly thing to state, but a lot of the logic that we have to use is going to feel that way sometimes. Sometimes people need an explanation for something that isn't as obvious to them. All right, but all right angles are congruent. If 2 angles are congruent and supplementary, then each one of those is a right angle. So let's go ahead and let's divide this up, and I've got this angle and that angle. They are congruent, but together they make a straight angle. If they add up to equal 180, then they must both equal 90. All right, and we can do kind of some step-by-step geometric proof there, all right, to show what our logic is in the left column, but then what our reasons are for each of those statements in the right column. The sum of the measures of a linear pair is 180. This is kind of just the definition of a linear pair, is that a linear pair is supplementary angles. And so if we recognize that we have 2 angles that make a line, a linear pair, 2 angles that together make a straight angle, then their measures must add up to 180 degrees. All right, so that's not necessarily anything that's super fancy. All right, so that brings us to kind of the end. I want to make sure that you can think through those ideas about supplementary angles, complementary angles, and vertical angles, and we will use that in class.